Hello everyone, this is our next fluid machinery lecture, and today I will explain you how you can deal with pipes or pumps connected in series or parallel. Okay, so in real life pipe system it is very common to have a couple of pipes connected in either series or in parallel. So this is an example. This is the water distribution system of Budapest. You see that this is a large system with an enormous amount of pipes, and clearly a lot of them are connected in series and parallel. Here I will give you a simpler bit. For example, these two pipes here are connected in series, okay? Or for example, this branch and this branch are connected in parallel. Or if you like, this pipe and this pipe is connected in parallel. Now clearly in this course we are not dealing with such complicated pipeline systems. However, we typically use parallel connection if we want to ensure redundancy, okay, or maintenance. So if one of the pipes is broken or you have to maintain them, you have to shut it out, then still there's another one which you can use. In the case of series connection, the most typical case is when there is a change in the diameter or a change in the pipe material, or as in this case, there is a consumption in between the two pipes, and hence the flow rate is different. Series or parallel connection also appears in the case of pumps. So we typically use pumps connected in series if we want to increase the pressure, okay? Although very often we simply use multi-stage pumps. Now pumps can be connected in parallel if you want to have a flexibility in the service. So for example, consider this pumping station. You have two pumps. They are both connected in parallel. And the aim of this connection in this case is simply to be able to cope with varying consumption. So if you think, for example, a water distribution system, in the night, hardly anyone uses water. So there's a very low consumption, whereas in the morning and in the evening hours, there's a large consumption, so you need to feed a lot of water into the system. Now, typically, instead of using one pump for such cases, we use several pumps, usually one pump which is directly driven, so without frequency control, that will serve as a base pump for the average consumption. And then in the peak hours, so in the evening and in the morning hours, when there's a large extra consumption need, you will simply switch on another pump, and hence these two pumps are connected in parallel. Okay, so let's speak first about the series connection. Consider these two pipes. So we start up with pressure 1, and then the blue pipe, there is a flow rate Q. The pressure drop is delta P1. So at this node here, the pressure will be P2. Now in the second pipe, the red one, obviously the flow rate must be the same as there is no consumption in between. But again, the length, the diameter, or the pipe friction coefficient can be different. So there's another pressure drop delta P2 due to the red pipe, and then the pressure at the last node will be P2 minus delta P2, which is simply P1 minus, so the first pressure minus delta P1 minus delta P2. So this simply means that in these cases, when you have two pipes or pumps connected in series, then the flow rate is the same, whereas the pressure differences must be added. Okay, consider this example. You have one base pump, S1, and then you have to ask yourself whether I should put the second pump immediately after the first pump or after some pipe length. Okay, so consider the blue case, the blue pressure. So pump 1 rises the pressure from ambient pressure to this pressure level here. And then if you add the blue pump immediately after the first pump, then there is another pressure difference. So here after the second pump, the pressure is the sum of the two pumps. And then you have the blue curve up to the reservoir. Okay, so this is the pressure distribution along the pipe. However, if you move the second pump here, then after the first pump you have a pressure drop because of the pipeline. Then you have the same pressure rise as here, so this height is the same as this height because the pump is the same. So the second pump again increases the pressure, and then you arrive again at the reservoir. So from the hydraulic point of view, there is no difference between the two cases. You increase the pressure, decrease the pressure, increase the pressure, and decrease the pressure again, or you increase the pressure in two steps, and then you have the pipe friction loss all over the remaining length of the pipe. However, there is a difference because if you use this case, then clearly this will be the maximum pressure along the pipeline, whereas if you use the two pumps close coupled, then you will get a higher maximum pressure along the pipeline. Nevertheless, the main message here is that if you have pumps or pipes connected in series, then what you need to do is simply add the performance curves after each other in terms of head, and the flow rate is the same. Okay, how does it look like in the case of parallel connection? Now, if you have parallel connection, then what happens is that the pressure difference will be the same, but the flow rates are added up. Okay, so this is very simple. If you have Q1 here and if you have Q2 here, then at the end of the day, between P1 and P2, you have Q1 plus Q2. The same can happen with pumps. So you have one pump, you have a second pump, you add them up, you connect them in parallel. So the flow rate, if this is Q2, the flow rate of the second pump, and Q1 is the flow rate of the first pump, then along the pipeline you have Q1 plus Q2. So this means that you have to add the performance curves at constant pressure differences, and then you add up the flow rates. Okay. Now, if pumps are connected in parallel, then what you have to be aware that naively you would think that if I'm using 2 or 3 or a couple of pumps of the same type parallel, then the flow rate will also double or triple. So say you have this pipe here, sorry, this pump, and then this is your pipeline system curve, and then you get this flow rate, and you're not satisfied with it because you want to have a higher flow rate. So you say that, okay, I will add another pump in parallel, and naively you would think that the resulting flow rate will be double. But this is not the case, because if you have two pumps like this, then this will be the new operating point, and the extra flow rate you get by adding the second pump is less. Okay, so what will actually happen is that you've added the two pump performance curves horizontally. So at this pressure level, this is the flow rate of the first pump, this is the flow rate of the second pump, this is the resulting flow rate. Okay, and then you can go back and this is the flow rate of the first pump, this is the flow rate of the second pump. But as you can see, as the pipeline curve is not horizontal, the intersection will be not twice as far from the previous one, but a lower one. Now, if you happen to add the third pump, then again, what happens is that you get a larger flow rate, but the flow rate increase is again smaller. And as you add more and more and more pumps, this is the theoretical maximum flow rate that you can achieve with these pumps at this pipeline curve. Okay, so you have to be careful. Increasing the number of pumps does not necessarily mean that the resulting flow rate will be also double or triple. Of course, if this pipeline curve is much less bent, so let's say, for example, something like this, then this is the flow rate of one pump, this is the flow rate of two pumps, this is the flow rate of three pumps, etc. Then you'll get larger increases. But if the pipeline has a significant friction loss, then this is not the case. Okay, so this is again something that's connected to chapter 3 in the updated lecture notes. Okay, and I will see you soon because I'm adding another video about the control of pumps. And for next week, for Easter's week, there will be no new video lectures because I want to leave you some time to absorb the system performance curves and the control and the series and parallel connection that we have had so far. Bye bye.